This is a replication of Eric Dollard's transverse electromagnetic, or TEM, analog computer. And it's an analog of something like 30 miles of transmission line, as described in one of his Borderlands Sciences videos. It's being driven by this car audio amp. Right now it's drawing 560 milliamps. The car audio amp is being driven by this function generator. 700 millivolts translates into about 8 volts peak to peak sine wave at a kilohertz at the moment. And as I bring it into resonance, it gets louder. And the current draw goes up. And now, with this magnetic and E-field meter that I have, I'm gonna sweep across and see where the magnetic field strength is the strongest. So here, down here at this end, it's not that strong. And as I get closer to that end, it gets stronger. Now, if I switch to the E-field reading, we see that the E-field is low down at the top, and as we get closer to the bottom, the E-field gets more intense. Most intense right there. Less intense down there. I highly recommend replicating this. You can find the exact parts that I used in Eric Dollard's Borderlands video. He mentions the exact inductances and capacitances that I'm using here. And next I'm going to hook it up in the longitudinal mode and see how that looks. Okay, here's the longitudinal arrangement. This time I had to use the scope to measure the resonant peak because the meter just wasn't accurate enough. So if I just go higher, falls out of resonance. If I go lower, falls out of resonance. And this is the third resonant peak this time. The other two aren't nearly as strong as the third, which is at about 32.5 kilohertz. And the coils don't whine nearly as much, but Let's see what the meter shows us this time. So if I put it in magnetic, we see that this time the magnetic rises as we get towards the output of the coil. And if I flip it into electric, we see that the E field intensity is quite intense toward the end of the coil as well. So here we have both the magnetic and the dielectric in space conjunction at this end, at the open end of the coils.